Did like a recording message pop up?
Yeah.
Okay.
Yeah.
So in case Blake or anybody else wants to see this, I guess I'll just set it to record and hopefully the audio and video will capture. Right. Can everybody see my screen?
Yeah.
Okay.
Yeah.
And if I write like this, is it appearing?
Yeah.
Okay.
It's clear.
Awesome. All right. So today we're going to go over some stuff for the base model. I know there is, so the assignment is really big. So who's gone over the assignment so far? Or have you read the one for like a group assignment for?
I've just read the rubric, but I haven't
Okay.
gone through the assignment itself.
Okay, got it. So just overall, what I'm going to try to explain today is just like some of the more of like the theory behind the base model. And it'll make it easier to understand what's happening in the article. Because what it's asking us to do is apply something that I don't think he went over really well in class in the first place.
Hmm.
So for starters, go over defining the base diffusion model. Um, so first of all, it's a model for products that you're launching, and it's really only useful when you have products in two states, which is the early adopters. That's one. And then the other one is going to be your imitators. And the general like word instead of the math, the word translation of it is when you start out with like releasing a product, you have early adopters that represent the bulk of whoever's purchasing your product. Later on, you have imitators who start representing a bigger and bigger chunk of who's purchasing your product. Now it looks a little bit better graphically. So let's say we're going to call this f of t and t as in time. So what we can expect with our model is at the very, very beginning, f of t is going to be what proportion of the market we're capturing. So this down, portion of market. Now, when we talk about proportion in statistics, what we really mean is anything between 0 and 1. So if you imagine this as a probability graph instead of a market potential total graph. So like let's say you had like 20,000 units of whatever you were trying to sell, right? Like 20,000 cars or something. Well, then the numbers would represent anything between 0 and 20,000 here. But to simplify the math overall, we just said it's going to be between 0 and 1. If f of t is equal to 1, you're basically saying that you have all of the market. Every single person that it's possible for you to sell to, you're able to sell to them. When the reality is somewhere between 0 and 1 is where you're actually going to end up. So if you have a curve that kind of looks like this, what we're going to see is at the very beginning, we have a proportion of the early adopters, right? So these people right here are going to be mostly your early adopters. But as you move on to here, what are these going to be?
The imitators?
Yeah, these are going to be your imitators. And when you get up here, what ends up happening is you don't have anybody left in the market, right? So between 0 and 1, when you hit 1, what we're saying is you got 100% of the market. You don't really have early adopters or imitators anymore. You got them all,
Right.
which was a really good point overall for when the base model matters. You have to have something that you can stratify into early adopters and imitators. If your product changes or you offer an additional service, all of this doesn't apply anymore. You have to create an entirely new model because what's going to happen if if something changes, if the market potential changes, So let's say if the market potential was 20,000 cars, but now it's 25,000 cars, right? So earlier I was only able to sell 20,000 cars, but now I'm able to sell 25,000 cars, which means that there's 5,000 additional people that I want to sell to, right? 5,000 additional cars that I can sell. The issue is that my market potential has changed. So if prior to this, so for a market potential of 20,000, we still had it ranging from 0 to 1, right? But the problem is one right here, this is 20,000. This is everything. So we can't go above this. What that means is that our proportion of early adopters and imitators is now wrong. So you actually need an entirely different graph to represent this. And this is something that happens like pretty often. So the base model is kind of an oversimplification. When you only have one product that you know you're going to sell a certain way, and there's no shot that the market potential will ever shift, then for sure you have it, right? It's a good model to use. If not, there's like a market adjusted base model, which is a more generalized one that we'll probably end up learning later at some point. And then the other way this changes is that let's say we're not the only company, right, that's going to be selling cars to people, right?
Right.
So this is the when we talk about like 20,000 cars here, we're saying that that's our market potential. That's our piece of the pie, right? But if you're, let's say the total market, it was like 100,000 cars, right? That means we only occupy 1/5 of that market. And
Right.
the funny thing is, if you add it up for every single other company, so let's say there's four other companies selling in a similar vein with different distributions, right? Some have 10,000 cars, some have 12,000 cars. Um, if you added that all up together, you're gonna find for the most part that it looks like exactly like this, except the total potential, it's gonna be like really, really aggressively S-shaped. So we're gonna call this part just the S shape, and it's kind of like an almost perfect representation of the base model. And from now on, we're actually going to be talking about a little bit of the math involved. But I'm not gonna like stress you guys out with any of like the details of the math because there's only really two things you need to know that look difficult because the equation he put up in class was kind of complicated. So let's just demystify that right now. Um, So first of all, we're calling f of t basically a function of time. Um, f of t is going to be our probability or basically our proportion of the whole market, right? It's the
Right.
proportion of our market potential. Then we define two other variables. We defined a p, and a q. Can somebody tell me what p is?
So P is like a variable that you put in, which you observe from other company that based on their models, you observe that um, they use they use this variable to determine what your model is gonna look like.
Mhm. So we call that an analog model. But I guess I'll be more specific in terms of what I'm looking for. Is this an innovator or an imitator?
The P,
Mhm. If our P is more important here and our Q is more important up here, which one's the innovator and which one's the imitator?
P is the innovator
Yeah.
and Q is the
hmm
imitator.
So you can think of P as the proportion of innovators. And Q is in the same vein is the proportion of imitators. And depending how much time has passed, one of these is going to be way more important than the others, right? Because at some point, you're not going to have any innovators buying your product. It's going to be just imitators. But when you're just releasing your product, your imitators don't matter because the only people that are going to buy a new product are going to be your innovators.
Mhm.
So we're going to go a little bit further into the kind of calculation for this, which is basically going to be it is your proportion of innovators added to your proportion of the market potential in its entirety multiplied by the remainder of your market potential. All right, now we're going to do a quick sidebar here. So the graph that he presented in class is a little bit hard to make sense of. It's hard to make sense of because what he's talking about is actually a rate. And when you're talking about a rate, it's a little bit more calculus related and it's about taking a derivative. So I'm going to do like a 10-second explanation of all the calculus you'll ever need to know. And the only thing that's ever going to be important for marketing. So the calculus lets you do two things. It lets you take either one, a rate, or two, an area. A rate is basically saying how fast. And an area is basically saying,
How big?
yeah, how big, how much. Right, exactly. So it's two really, really basic things. Now, the important part about it is that you'll like semi-often see a symbol that looks like this. DDT means take the derivative with respect to time. What it's really saying is how fast, right? And whenever you see this is an integral. What it's really saying is how much. That's it. So when we're talking about something like FT, if FT is equal to the proportion of the market potential, then when I say take the derivative of this, what do you think it means?
How much does the proportion change?
That's it. It's how the proportion changes. That's all we're trying to get to. And that will make this graph right here make a lot more sense now. Especially when we take, so we're going to be talking about P here and then Q here with some very, very specific conditions again. And what this is saying is we're going to take the rate of the market potential of our proportion of the market potential because ultimately what we want to find out is how much and how fast our market potential is growing, right? So we want to see what's the bigger contributor. Is it going to be our innovators? Is it going to be our imitators? Whatever it is, we just want to know how fast we're going to grow. And at any time t, if I were to ask you, if we were talking about t, let's say it's in months, right?
Mm-hmm.
So when we talk about cycles of t, what I'm saying, if t is equal to 7, I'm saying in 7 months. In 7 months, where do we land on here? Is it here? Is it here? Is it here? Right? Because depending on where we are, it's really, really important to know Okay, so we're 7 months out in whatever our product release is. Are we still technically in the innovators phase, right? Are the innovators the only ones that are still purchasing our product, right? And if we looked at time cycle, let's say 25, so 25 months, we're a little over 2 years out. Is it at that point that we see more imitators start purchasing our product? Do they become the bulk of our of the people who are trying to acquire our product right now? And depending on where that T is exactly where this is what's called an inflection point. So this inflection point really determines where we're at, like as a product release at a company, wherever. And then the general knowledge about this is that most companies don't reach this inflection point. So the BAS model, it works for a lot of things. It's just one of those analysis models where if you pick it, you need to be really sure that the the information you're giving it is accurate for how your market actually is, right? So in the first condition we said is like well, for one, you can only have really two kinds of people. You got your innovators and your adopters. Two, your market potential can't grow. So if you have a market potential that starts at, like we said, 20,000 and then suddenly it becomes 25,000, this entire model fails. And depending on where your inflection point is, you might never get one. So you might never get like a sustainable sale of your product and capture the percentage of the market potential that you're looking to. And then on the converse side of this, if you created a BAS model for whatever product you're releasing, and like Amber was saying earlier, second, don't know what's doing that. Okay, can everyone see it again?
Yeah.
Yeah.
Okay, awesome. Okay, so what was I saying earlier? Okay, so like Amber had explained earlier, when you take P and Q estimates for other products or other companies that are producing like the same thing that you're trying to create, we call them analogs, and your analogs actually help you determine whether or not your base model is accurate, right? So if you're like 12, like 12 months out or something, one calendar year, and your BAS model is saying something like, oh, you should be capturing like 65% of the market potential. But as it turns out, when you look at your actual sales, you're somewhere closer to like 35% of the market potential. What that means is you actually have to figure out, did I estimate my market potential correctly? If we're using an analog or data from other people's analysis, is that going to be accurate for what we're trying to sell? Are we occupying like an entirely different place in the market? So that's kind of like the general consensus for when to and when not to use the BAS model. And now I'm actually going to return to, God damn it. There we go. I guess if I stop writing, it disappears. I'll have to look at the settings. Okay, back. Okay. So earlier I was talking about how when you have a P and Q, right? You're going to have what is essentially your P, which is your innovator, the proportion of innovators, plus your Q times your full market potential. And then this is going to be all multiplied by 1 minus your full market potential. And I'm going to make this part right here really easy to understand. So if f of t is all of the people we want to capture in our market, by proportion, it is the proportion of people that we want to capture in our market. If you had to guess, what is 1 minus ft? So it's who's left over, right? If I've got 70% of the market and I do 1 minus 70%, that means 30% is what I don't have. So this is everyone I want to get still. And what we're doing here is we're taking a rate, it's a rate by multiplying everyone we want to get who's left in the market multiplied by everyone that we have right now, basically. That's all we're looking at. So it's not like super, super special in that regard. And the only weirdness with the math comes from the P and Q that we can actually investigate graphically. So if you're gonna like look right here, and in our formula, we have P, we're gonna have a P that is much greater than a Q at this very beginning before our inflection point. And afterwards, we're gonna have a Q that is much bigger than the P. Now, what this means mathematically is when I say when we're starting out, right? When we're starting out and we have captured 0 people in the market. So this is a new product. So for a new product, we actually set FT is equal to 0 because we haven't sold anything yet. And what ends up happening in the formula, when you set FT is equal to 0, you end up with the rate at which our market potential is growing is just going to be equal to P. Because all of this stuff, it's going to be P times 1, which is P. So all of this stuff cancels out. Now, this is just a mathematical way of saying that when I have a new product, would you expect Q to have a value?
Not really.
No. Why?
Because you don't have anyone in your target market. There's no one there.
Yeah. Yeah. Q is 0 because we have no imitators. We only have innovators at the very start, the people who are really wanting to get that product instantly. So it makes sense that for this very beginning graph that we have, at this point, the only thing that matters is P. It's going to be P is much bigger than Q. And then as we move along, we start seeing that the proportion of innovators is, if you look at them with a ratio to the proportion of imitators, the imitators start to gain a lot of traction, right? So they're at this point, you're gonna have Q is much bigger than P. Which is, once again, just our way of saying at one point in time, you can't expect your innovators to be continuing to buy your product. After you hit this inflection point, pretty much like the overwhelming majority of whoever's purchasing your product is going to be an imitator. Which now if we like look at this this formula again up here, what we're talking about is essentially a weighted average. Because what we're saying is that at the very beginning, we've set up this equation so that P matters more. But towards the end of the time periods, or whatever we're defining as our time periods, Q matters more to us. So we're actually assigning which one we care about more just by writing the equation. Now, I am going to go a little bit into, we won't do that part. So let me just get a little bit of feedback, like where we're at so far. How's everyone feeling?
Good.
Yeah, I feel a lot better about it.
Okay, cool. Because I'm going to move to this next part, which is like the actual kind of like calculation of what's going on. And we're going to be able to see kind of in real time how you actually plug in data, because all of this is like super theoretical. But as long as you understand like why we use the best model and when we use it, that's probably the bigger takeaway compared to like all the math. Because like there's already lots of computer algorithms that do this automatically. So
I
we're
have a
actually, yeah. What's up, Amber?
sorry. I have a quick question. So how did you define your equation? Is it from our textbook or
That's
you
actually
define it?
that's a very good question. This is not the equation that we use for calculating what's happening.
Uh,
And that's mostly because the equation is really bad for explaining what the best model is.
okay, I
Yeah.
see.
So this is like a much more elegant way to describe it, because once again, he never in the class, he never really used the word rate. He used the word proportion, but what you're really looking for is the rate. It is a rate of a proportion. So once again, because
Mm,
you don't in one point we are looking at like, okay, this is how much of the market that we have. But we're also looking at how fast we're growing, like how much of the market share we're taking up and how fast we're taking it up.
I see. Thank you.
Mhm. So the actual formula uh, is going to look a little bit like, okay. So when, I don't know about you guys, but whenever I read a formula like this, my brain kind of, dies on itself like a collapsing star, because it's way too much, way too fast. So instead, I usually prefer to just break down equations into words, because then I can actually understand what's going on, right? So we already said that P is what? It's the proportion of innovators.
Innovators.
Yeah. And then we've defined like M is what?
Um, M is the total market.
Yep. M is total market potential. And then we're gonna have so there's gonna be a little n and there's gonna be a big N. The little n refers to a snapshot, and the big N refers to cumulative. Um, all all that means is that when you have the little n, you're only really looking at one time proportion, whereas when you're looking at the big N, you're looking at all of them. So I think I should probably switch over to the notes it's made over, because these might make more sense. Okay, so yeah, this is probably a better graph for that. You have two basic models that we're going to look at. There's the non-cumulative, and then there's the cumulative model. And the non-cumulative model tries to separate what's the adoption by imitators versus the adoption by innovators. So if you actually look at this part right here, the blue line is referring to the innovators. As we can see, like it has a value when it starts off, right? But then it actually levels off and it starts disappearing. And conversely,
Mm,
when you look at the adoption by imitators, it starts at zero because there's none of them at the beginning. But at this point right here where they intersect, that's going to be your inflection point. And the little n, once again, is going to refer to that snapshot. But when we do cumulative values, that's when we use the big N. What we're saying is I'm adding up this graph, and I want it on one, like exactly one graph. I want to see everything at once. And once you do that and you go over the time scale again, you're going to find that S shape happens again and again. So, So this is the part where I define the variables that we're going to be working with. So M is the total market potential. And once again, we have to assume that it's fixed. If it's not fixed, we're actually in a lot of trouble, and this model isn't going to work at all. The little nt is the number of adopters in time t. Once again, that's referring to the innovators and the imitators together. And n big N of t is referring to the number of cumulative adopters until time t. The best way to think of something like nt is, or big NT, is that if you took every single possible graph that you could have for the little n one and you added them all together, that's what gets you the big N one.
So
And
like, I'm sorry. So like, for example, capital capital N3 equals to small n1 plus small n2 plus small n3,
yes,
right?
yep,
Okay.
it is a summation. So yes, you can add up as many of those graphs right here as you can get, and then you're going to get this guy down here, right?
Okay.
And then when we look at the n minus nt, what that basically means is the when I said earlier you have the 1 minus f of t with a different formula, this is the exact same thing. It's just saying this is whoever's left in the market that we haven't got yet. This is who we want to get, right?
Great.
And now we're gonna do, this is like my way of like verbally breaking down an equation. So what we're looking for is the probability of adoption at time t, given that it has not yet occurred, right? So we're looking for basically at any time point, what are the chances that we're going to capture a little bit more of the market? And that's going to be equal to P, which is the once again the proportion of innovators, and then we're going to add that to the cumulative fraction of adoptions until time t. And I'm going to break this down a little bit further. Scroll the way up. Never mind. So if you look at the proportion of innovators down here, the actual equation for that is the little n of t divided by m minus big N of t, which in words just means this is the number of adopters in time t that we've had so far, and then we're going to divide that by who's left in the market. This is the proportion of like who we have so far versus who's left in the market. That's it. Whereas this other one, Q times big N of t over M, it's basically just the proportion of imitators multiplied by the cumulative number of adopters divided by the total market potential. So this is who's the first one is going to be just the innovator side, and then the second one is going to be the imitator side. And the equation is created when you add these two together. So Pn is actually representing this first part, just the innovators, and then all of that other junk is going to be the imitator effect. And the reason the imitator effect, just like this is more like conceptually, has a kind of more difficult or complicated formula, is because imagine it's like on a punishment curve, right? Like the more imitators you get, the more it's going to level off, because the more you're going to get closer to your full market potential. So this right here, this portion of it, the reason that you have a squared at the end of here is that edge of the curve. That's what's happening. And so he put a lot of stuff up there, basically talking about like the ABC, and he added like 3 additional equations. I'm going to ask you guys to ignore all of it because it's not really good for understanding what this is. The only takeaway you need to know is that the equation that you see up here, so let's see. This equation is kind of what we have to describe what's going on. It's pretty accurate. And what we needed to do is we asked ourselves like, hey, how do I turn this into a graph? So the graph that we're actually seeing is based on this equation. The problem is that this equation is not really good for graphing. You have way too much going on, and you need to know what your coefficients or intercepts are going to be. So they made it really simple by saying this is a format, f of x is equal to a plus bx plus cx squared. It is a quadratic function, and we actually know how to graph it. Like we're proven to know how to graph it. So instead, it's one of those deals with this equation. What we did is we want the square peg to fit the round hole. We're saying that I'm gonna take these values up here, and so I'm gonna make this PM become A. That's it, because I can graph that. I'm gonna make this Q minus P part up here. I'm gonna turn that into a B, because that's easier to graph. And then this minus Q over M, I'm going to turn that into a C, because once again, that's a lot easier to graph. And so those coefficients don't really mean anything because we're the ones who define them. And once again, it's just because we're trying to make it possible to graph. The actual calculations aren't that important. So we're just, like it says down here, we're just creating coefficients to make this work. So any questions so far?
No.
No. So, and
I actually have one. So the M doesn't represent the total potential market on, sorry, can you go back to your equation?
yeah, yes. So this part, right?
Like, yeah. So
This
this
part.
M doesn't equal to the total potential market, right? It means the slope of the
It
function,
does.
right?
It does. That's why I
It
separated
does?
it. Yeah, I separated it from the other
Oh.
ones. It doesn't quite, and it's the type of calculation that you put up on a whiteboard when you want to confuse the hell out of people, because it does not really help you understand why we're doing it this way. This is called the process of linearization. We take something that's not necessarily linear or might be linear, and then we try to turn it into a line or a curve so we can actually see what it looks like on a graph. Because when we see what it looks like on a graph, it makes it a lot easier for us to decide if our model actually works or not. Because sometimes you'll get data that's it's exponential, but you try to graph it normally, and you'll find that a line of best fit just isn't possible. And what we're doing here is kind of to avoid that.
Okay, thank you.
Yeah.
I see. That's interesting.
And then down here we had the example like question basically. And for every calculation that we're going to do, this right here, so this right here is the main equation that we're going to be dealing with pretty much everything. This is the one that's the most comfortable for like substituting numbers in, because what this is saying up here is that you have your innovator contribution is going to be 0.01, and your imitator contribution is going to be 0.5. And then it's also saying that your total market potential is 30. So anybody want to recap what I said? What happens when your net market potential is 0, like right when you're releasing a product? What's going on?
There is no one there, so P means 0.
Q is going to be 0 on this one.
Oh, Q,
zero.
Yeah,
it's Q,
no worries. Close, yeah.
Sorry.
So, no, it's okay. Yeah, and we can see that like really, really easily through the formula, right? Because if you substitute in NT as 0, what's going to happen? It's just all you're going to end up with is this entire stuff is just going to go away because it's all multiplied. But on the left side, you're still going to just be left with P multiplied by M, which is in word terms, what we're going to say is it's my market potential times the proportion of innovators that are actually purchasing my product. And that's another way of saying my innovators are the only people buying my product. And at the very beginning, when I release, I can expect like 0.3 innovators. Like if you turn the market potential to like 300 or something, you would get like 3, right? So that would be like a nice round number. Like, okay, so I can expect like three people to purchase my product at the very beginning. But if the BAS model holds true, we can expect that eventually what's going to happen is we're going to get an increase in these innovators purchasing it, but afterwards it's going to be the imitators that are going to be mostly responsible for all the purchases, right? And it's actually really easy to see that right here, because if you're comparing P and Q on this part, Q is 0.5, right? So that's like almost like saying at some point in time, they're going to have like a 50% contribution, a proportion of all the products that I'm trying to sell. Yeah.
Yeah, that
It's
makes
just,
sense.
yeah, it's just at the very beginning, the formula punishes the formula punishes
Imitators.
the imitator side. So this is imitator side, and then this is innovator side.
Innovators.
Yep. So I hope that makes it a little bit easier to understand. And so the next question is another one. I'm gonna kind of go over it a little bit, like the concept behind it, because it's talking about like how much it's really important, like saying like how much time do I need until I capture like 50% of the market, right? So you know, like if you have a market potential of 30 and you want to capture 50% of the market, how many people are you gonna try to capture?
15.
15, right? That's simple. So the thing is, we know that that number is 15, but it turns out to actually get that time t, there's some kind of super annoying math involved in getting it. Especially when you have like very few variables provided to you, you would need like a chart of information, and because what you would be looking at is once again time cycles. So So a market potential, if this, you know, is n up here, right? You have 0 and 1. What right here is going to be what?
Yeah,
50%
50%.
of the market, right? So what we are actually trying to find down here is something like something like that, where it fits on this curve right here, roughly. Like at so the what it's really trying to get to is at how many time cycles do we have half of the market, right? So does that make sense?
Yeah.
Got it. All right. Any questions? No?
No.
Moving on? Okay. And then remember, if some of this is like confusing, I am gonna post a video of it. So you can like go back and rewatch it. I'm also gonna start going over like our actual assignment now. So we'll like review some stuff.
Hey, yeah, Anshu, you don't mind if I share this with
Not at all.
anybody else, right? Cool.
Yeah, whoever needs to see it. Yeah.
It's good.
Yeah, so we're gonna go down to okay. So does everybody have like the assignment pulled up?
Yeah.
Yeah.
Okay. So from what I understood, you know, in like a cursory reading, what seems to be going on is we're releasing a product, the CleanBot, but the assumed projections for it like aren't very good based off of qualitative feedback that we've got from people that we're trying to test it with, right? So coming down to here, what this is saying is percentage distribution of household income in the United States. Let's see if I can. Is it a little easier to see? is.
No, I
Is
don't
my
think so.
is my screen sharing?
What we see is the drive. You're like notebook,
Yeah.
whatever.
Oh, okay, okay. Let me. How about now?
Yeah.
Yeah,
Okay,
good.
Yeah, I
okay, you
can
can
see
see.
it.
Awesome. Yeah, yeah. So this is the percentage distribution of household income. And what we're going to be primarily targeting based off of what the kind of article is telling us is that we want to be like right here. Households that make like over 100K, basically, right?
Mhm.
So if you're, I guess, like segmenting that population of total households, it would be like the
35.8.
yeah, the 15.9 plus 8.3 plus 11.6. What was the number again, number?
35.8.
35.8%. Got it. And this is everyone over 100K.
100.
Yeah. See. And then there's the shopping intention, I guess, for like um what type of vacuum people are saying that they're interested in purchasing. And then of course there's like how much they're willing to actually pay for what specific type of vacuum. So I think all of this background information is supposed to be for like our chain ratio calculation, where we're trying to say like, hey, like in a total population of people, we want to continuously segment it downwards so that we get an approximation of who we're actually trying to sell this to, right? In the example of that is like if you have, I don't know, like 100,000 potential households, based off of the household income, you could probably only say like I can only sell to about 36% of them because my product is so expensive. It lands in this zone right here. So that means I can't actually sell to anybody else right here. So this is what you would be doing for primary segmentation. And then, so you're saying of that 100K, you'll only be selling to the 35.8%. And then down here, if you can find a way to like further segment that, say like, okay, this is like of all the people in like of that 36% of them, I can only sell like once again 36%, right? Because this is our product, the robotic one. So they're saying if there's a distribution of appetites for our product, only this proportion, like about a third of people, will actually be interested either way for buying our product. And then if you go down here, like even further, people who in general are willing to spend 300 or more, it's in total around like 20%. So
Yeah.
you end up with the calculation that's like if you started at 100K, um like just in your population, 100K is 100,000, we'll say, is for we'll call it our sample size at n, segmenting that by 36%, then segmenting that result by 1/3, and then once again segmenting that result by 1/5. That number is everyone you have left to sell to with the chain ratio
Holy.
method. Any questions about chain ratio?
No, that makes sense.
And this is also like more qualitative. We are actually estimating. So as long as you have like a decent justification for why you picked a certain percentage for chain ratio, you're pretty okay. Oftentimes you'll have also like an industry standard estimate for whatever you're looking at. Because in this example, if we scroll down, we'll see.
So are we targeting about 10 million?
Yeah. Whatever. See, I haven't even been able to look at the exact number yet because I was still
Yeah.
deciding on the chain ratio right before I hopped on. But Yeah, we can do 10 million if that's what it says somewhere on here. The most important part was the fact that there are innovation indexes and imitation indexes for similar products in that
So
vein.
and then we still have to further segment it because the average household is 3.3.
Yeah.
So that would be 10 million. Really, it's like 3 million households or 3.5 million households.
So let's see if I can pull up.
Yeah, we're looking at 30 something
Yeah.
percent of 332.
So
That's
this is
about 110.
I also asked ChatGPT to give me an estimate for segmentation, and this is what they come up with, which is basically like if you have a total population of 330 million people, around 2.5 people per household, it gives you around this many households. You have additional market potential calculations, and once again, I didn't enter the information that we had. So this is just an example of how it gets its own chain ratio.
Gotcha.
And yeah, it turned out somewhere around like 2 million units. So I don't think it's like super far off from where we're at,
Okay.
scale wise. Yeah, but it's the thing about chain ratios, as long as you justify why you segmented the way you did, you're okay.
Okay.
And then of course I had it. So what we're saying, right, what she's saying right here is that we have believed innovation and imitation indexes closer to 0.04 and 0.34. Um, it's a hypothesis, right? Like she's basically saying that like our numbers aren't very good, and we're not entirely sure. So we're going to use this as an estimate for our calculation, and perhaps using other people's estimates isn't as good for us, because maybe our product is like different in some meaningful way that would cause our innovators and imitation indexes. So our graph is going to look a little bit different from theirs. Um, and so I basically had it do a t is equal to 20 time cycles graph for this. And this is what we get. We get the adoption over time base model, base model, and the cumulative adoption over time. As you can see, the original, this is like your little n t model up here, and this is your big N of t model down here. This is going to look more, the big N of t model down here is going to look more and more like an actual S, right? And the other one, the little n of t, is going to look more like a kind of generic curve that tapers off. And it's also worth noting that this is a snapshot of adding both the innovators and imitators. And that's going to be even more clear when you look at this. I had it map out the actual innovators and imitators over time graph. So you can see that you have your innovators starting off somewhere here with a value and then depreciating. And then over here, you have your imitator starting off at 0 and picking up steam. This inflection point right here is what you're going to see right there, where you have this curvature start taking off. Yeah.
Sorry, Ansh, I think your screen is still on the assignment page.
What?
So
which page?
Page 10. I mean, are you referring to any graph or something you created?
Yeah, I am. What are you guys seeing right now?
Page 10 of the assignment.
There. So is what you're seeing, are you seeing me scroll right now?
Yeah.
Okay. It's weird. I'm gonna try this again then. Okay, what do you see now?
Your ChatGPT.
There we go. Okay. So I'll do a quick recap of this part. This is the segmentation based on chain ratio. If you ask it to do a chain ratio method and then give me justifications for how you landed on that number, it will attempt to do something similar to what's available to us inside the StatLeap documentation. But what I really tried to do is conduct the best model analysis using the P is equal to 0.04 for the innovators and Q is equal to 0.34 for the imitators. What this means is our first graph is going to be one of adoption over time. This is your little n of t, and then your other one is your big N of t, your cumulative model, right? Your cumulative model is going to be the one that looks like very S-like, right? Comparatively. And then this one is actually created by, once again, like kind of condensing your imitators and innovators. And this is a little bit more challenging to see because it put it in one curve and just called it adoption. So when you ask it to say, produce both for me instead, this is our graph of innovators who start off at this point and then taper off. And then you have your imitators who start off at 0, as we expect, and then pick up steam and start representing the bulk of the adoptees. And this inflection point right here is actually partially visible on this graph. So this is where you see that if you took the derivative or the slope to find the rate of change of adoption, basically, your P is going to start mattering way less than your Q, right about right here. And it maps almost like 1 for 1 down to it right here. So any questions? And as a caveat, I could not get StatLeap to work. So I was stuck doing this. And then you can even ask it like, so these two are concepts, peak adoptions and time of peak sales. I'm having trouble remembering. Did he explain either of those?
I don't think so.
Okay. So let's see. There's two equations that have to do with this. It's basically I'm resisting explaining this part because the math is really annoying. There's like a natural log in one of them, which it's basically like if you ever a natural log or log transformation is done, whenever you have something that's like a curvy graph that you want to make a straight line, you natural log it. So it basically tells you there are equations based off of these graphs up here, specifically this one, where you can much more easily calculate like at what point do we have like the most number of people, the biggest percentage actually adopting our stuff. So that's going to be like really visible right here. You're able to still see the graphs, right?
Yeah.
Yeah, okay, good. So this is your peak number of adoptions calculation right here. That's m. It's m times p plus q squared over 4q. It's awful. All the math in this is awful. So we're gonna like brush right past that. And also look at the time of peak sales. So if you have a number of peak sales or of adoptions, basically that's right here, then your time of peak adoptions is also right here. So it'll be around this area too. And in terms of, if our time scale is years for this, then this would be years. Like at 7.4 years, you can expect to have the highest growth in your like adoption, number of adoptions, whether through innovators or through imitators. And it is after this point where you'll start seeing the slope depreciate. Because eventually we're going to get to a place where nobody else is actually adopting our product. We're actually getting very close to the entire market share.
I have a question. So we don't really need to use the above picture, right? Because if we do the TDF to the equation for the cumulative adoption over time, we should find that the slope at 7.4 is the biggest.
Yeah.
So that explains that at this point, we have the most people adopting our product.
Yeah.
Right.
What the thing is, what makes this first graph useful instead of the cumulative one is you get to see it as a snapshot and not cumulative. Because if I asked you to give me the
Okay.
highest value on here, this is a
Mm,
probability chart. It's not highest value isn't really an accurate way of explaining what the chart is. We're looking for numbers that are essentially between 0 and 1. Um, it did
okay.
something a little silly on this side, but it's 0 and 1. When you reach here, you have 100% of the market. When you're down here, you have 0% of the market. And then this one is an actual number that you can work with, an actual year and
Okay.
an actual the year. You're right. The year will be preserved on both graphs.
Mm,
It's just that the y value is going to be different. You might want the actual one.
I see.
Let's see. So when I asked it to calculate the peak adoption, it says on time cycle. What this is saying is uh, the peak adoption would be around 210K units occurring in year 7 or time cycle during time cycle 7. If it's years, it's
Mm,
within 7 years. You're going to be seeing the total adoption hit 210,000 units. And once again, this calculation, it's always better to let like a computer do it because if you don't have the values on hand, it's not that easy to get. Even the actual time cycle calculation is not fun. You usually need like a chart, and we use something called a stepwise function in machine learning to basically say like, I'm going to increment this number by like from if you're looking at like time scales for like 6 months or something, I'm going to say like at 0.1 months, it's this value. At zero point 0.2 months, it's this value. At point, so I actually have to go through and chart every step in between. So we really don't want to do that with this.
yeah.
Mhm. Okay. Any questions in general? Or I'm hoping this is helping any like all of y'all who are about to like read more depth in the assignment in more depth. That this will kind of put it into context of what the best model is, what it's supposed to do, what it can and can't tell you.
Yeah, most definitely.
Uh, I
Now
have
I
a
can
question that
now I can make
I'm
sense of
sorry.
it. Yeah,
What's
sorry
up?
about that. Go ahead, Amber.
Yeah, we understand the concept of the graph and the equations, but like, how do we apply it to our assignment? I mean, the assignment, it says like we have to make decisions and do analysis for this company, but like, how do we apply our model to make a business decision?
Yeah, that's a really good question. So, what we're saying is that we have a product that's very well represented by the base model. So we have some security in knowing that we're going to use the base model to predict what our sales are going to look like over the next few years. We're trying to say like what percentage of the market can we capture, right? From the very beginning of the article, it says that we had such high hopes for CleanBot Pro. How could it not resonate with our target audience, right? So what they're saying is that it hasn't tested well qualitatively. It doesn't resonate
Mm-hmm.
well. So instead, what we're trying to do is we're using an analog test. Let me pull up the analog. So these are our industry analogs, right? So what we're saying is that in our competitive space, we have other people who are producing specialized vacuum cleaners, industrial robotic automation devices, autonomous vehicles, and smart home assistants, right? And these innovation and imitation indexes that they have, these are not estimates. These are actually data that they've collected like over the last 5 or 10 time cycles, whether that's a year, months, or whatever. So this is actually this is like truthfully their actual indexes, what's
Mm-hmm.
happening in their company. The
Mm-hmm.
difference between them and us is that they have their product on the market. We don't have our product on the market,
Mm-hmm.
like at all, right? And because we don't have our product on the market, we can only use their analogs to test what our model would be. Now, up till now, my understanding is they've been using this model, these numbers right here, to indicate, oh, based off of how they're doing, we should be doing about that well. Except because our qualitative analysis have revealed that customers are probably not that happy, or they think that the CleanBot, whatever device is too complicated, that don't feel as good about the product as we think our product is, right? So instead of using one of these innovation and imitation indices, we're actually creating one of our own, an innovation index of 0.04 and 0.34. So this is our estimated analog. Does that make sense?
Yeah, I understand. I, yeah, but what I was talking about is that, like, for example, question number one, it says we have to do like specific actions um to encourage our customers to adopt our product.
Mhm.
So based on these numbers, like how do we generate our actions and how do we decide how we gonna do it?
Yeah. So this is going to be built around the big five elements of product
Uh-huh.
right here. The relative advantage, compatibility, complexibility, trialability, and observability. We're basically going to break down each of these 5 points into a more granular way, where we can say like, okay, this is you've given us in this article kind of like a blow by blow of what our product has, what it does for customers, what are its advantages, what are its relative advantages compared to a lot of the other products, right? So this is more of the writing qualitative element of the assignment where they're saying, okay, basically tell us why this product is better than the others and
Oh
use
yeah,
use
so
these 5 points to defend whatever your assertion is. Is it more compatible with certain stuff? Is it more or less complex than whatever else is out on the market? And if it is more complex than what's out on the market, is there a benefit because it's complex? Like, is that a feature, not a bug? Trialability, in the same vein as like, okay, we've handed out the product. I think it was a sample of like 300 products to like friends, families, people who are going to test it. Are they going to enjoy it enough to continue using it or recommend that others purchase it? And then observability, if you go to somebody else's house and they saw a CleanBot Pro, do you think that they would want to buy it after they saw it? Like how much does it catch on?
okay, so this part is gonna be like more like a descriptive part. We
Yeah.
have to observe what we see and
Mhm.
yeah, what the market is gonna be like.
So the first part of the question talks about a qualitative forecast where it's basically saying like based off of not any math, based off of what your intuition and your understanding of our product and where it lands based off of this framework, what is your expectation of it? Do you think it's going to sell well? Do you think that it's going to make a big impact? Do you think that we're going to be able to capture a significant portion of the market? And then the second part of this assignment is the actual mathematical element of it, where it's saying like, okay, we have the BAS model, which is an analysis tool for forecasting what percentage of the market will attempt to adopt our product, right? So based off of the qualitative side, what we said, what we think, intuition, how does that line up with the actual math behind it? And for the actual math behind it, we're using the estimators of, our innovator proportion is going to be 0.04 and our imitator proportion is going to be 0.34. So
0.34.
yeah, so they're saying make your analysis based off of those values instead. And then kind of part three is combining part one and part two.
Oh, I see. Oh, now I understand.
Mhm.
So number one is the qualitative question and number two is quantitative question.
Yep.
I see.
And then number three will be like the big write up on which we'll basically be talking about which one is better or worse, or I guess not, that's not a good way to say it. Not better or worse necessarily. It's more like, does your qualitative analysis line up with your quantitative analysis? Like if your qualitative analysis is saying that like, hey, our product is really great, it occupies like a better space than every other product on the market. It has a huge relative advantage. It's more compatible with things that people already have. It's not as complex as we took it to be at the beginning. Incredible trialability and observability. People see it, they really want to use it. Anytime somebody does use it, they really want to continue using it. And then if we look at our actual like BAS model math, And once again, the output that I showed you on ChatGPT was using my chain ratio method, not the chain ratio method recommended by the article itself. So our numbers are going to be different, our projections are going to be different. But I just wanted to let you guys know that even if StatLeap is kind of shitting the bed on this one, we still have a way of getting the information we're looking for. Because ultimately, if the stats behind it tells us that like, oh, you have like a peak adoption time of something of like 12 years or something, right? Like that, it's like that's too long. We know for a fact that that's way too long for something to catch on, right? The company is going to fail long before then.
Yeah, it's too long.
Yeah. So we just have to kind of like that because I don't think that there's necessarily like a right or wrong answer for this question.
No, I
It,
think you
it, it
just have to
depends on how you
defend it.
set you have to defend what you chose, whether it's your chain ratio method, your analyses, or your qualitative understanding of what's happening.
So basically, we are. Shall we do number 2 first, and then we do number 1 and then number 3?
Yes.
Because I bet that no one in our group knows much about vacuum or like these robots. So we're basically kind of imagine how this market might develop, right?
So, fun news. Well, we actually have one of those robots in our house.
Oh, really?
Yes, I think it used to be called a Roomba, but we got the one that's called iRobot. We have
Oh,
not
iRobot.
we have not used it in like 6 years. So that probably says a lot about where we are with it.
Okay, that helps.
Yeah, but I think instead of personal experience from the product, we're looking more at like we're corporate shills for all of this stuff, right? We're saying like our product is the best, it's really good. We really want people to buy it, we want to sell it. So our qualitative analysis is really supposed to promote the strengths of our product and diminish the weakness in the eyes of purchasers.
I was muted for a second when you said that, but you haven't used yours in 6 years. We use ours like 2, 3 times a day
Nice. Yeah.
because we have a dog, so every time he goes outside and
Mhm.
lays on the grass and he comes back in and there's like the iRobot is perfect for that.
Mhm.
All those light tasks and stuff. So
Oh
we
yeah,
use
I have.
it.
Yeah,
We use it
I
like
use it
two,
as
3 times
well,
a day.
but I mean, I'm not so familiar with this market, so I was just saying that I'm a user, but I don't know much about this market.
Mhm. Yeah,
I
and
sell houses, and every time, like I just recently closed one, like maybe like a month ago, a little bit over a month ago, and I gifted. That's one of the things I gift to my clients, and I always get the
Mm,
same thing. Oh my God, I was gonna buy one, but
mhm.
people, it really is. It's funny you say that because my last client, I think her salary was about 98K a
Mhm.
year, and she thought that at $400 it was too expensive.
Mhm.
So she
mm,
she didn't buy it, but I got it for her. So like some of this stuff does match what we're
Mhm.
seeing in
Yeah.
real life.
And in our home, the main reason we don't use it is because we are constantly changing configurations.
Oh, moving stuff
Yeah,
around.
we move stuff around constantly, so it doesn't learn. Every time you
Then
knew it,
you
it's
need
literally learning for the first time.
then you need the newer model.
Yeah.
It's honestly, it's true. There's one. I think that's why they innovated
Mhm.
the newest model. It continuously learns. I have the older model. As long as we don't move anything, we're good.
Yeah, that was our model.
Or you can just
Yeah,
buy a cheaper one which don't recognize how your house look like. They
and
don't
it'll
build
just
models.
clean.
Yeah.
Right. But so are we all feeling a little bit better about like approaching the group assignment?
Um, yeah, I think so.
Okay.
I think so too.
All right.
Should we link up again at some point?
Yeah, I don't know what everyone's availability is tomorrow. But I have a midterm and then after that I should be free. So like
So like,
probably between like anytime after 1:32, I should be okay.
well, I know for a fact that Bart and Blake have that 2 to 5. I think they have quant. Oh no, they have 205. So they're
Mhm.
free after 5.
Yeah,
I know
I'll
for
be
a fact.
free like any time after 2. I pretty much want to get as much of it done as I can. Because Wednesday is like very, very
Yeah.
impacted for me. Yeah.
Mm-hmm.
No, and I think it's good that we did this and then we spent a little bit more time tomorrow and then just button it up on Wednesday.
Yeah.
Because even though our last one, we were like, I know you were in class, I was in class, and we were like trying to get stuff done at 9:15 p.m. and we still got a good score, but yeah, that was cutting it too close
Mhm.
for sure.
And I've made an appointment with for office hours after class on Thursday to talk to the professor about like grading criteria and stuff because it seems like there's a pretty huge variance for scores like all around.
Mm-hmm.
So tomorrow after 5?
Yeah, I mean,
Sorry, I can't do after 5, but I'm available between 2 and 5.
yeah, so I'm anytime 2 and onwards. I'll be there.
Okay, so I meet you around 2, whatever you are, and we
Mhm.
discuss first, and then you guys can work on it after 5.
Yeah, got it. All right. And then we'll probably just meet in like the School of Business building for that.
Yeah, sure, it
Yeah,
works for
a
me.
little bit easier. Okay. Awesome.
Sounds
All
good
right.
to me.
Oh, is there people
Oh,
saying stuff in the chat? Oh, okay, okay.
no, that was just Bart. Thank you.
Got it.
All right. So tomorrow after 2?
Yeah,
Yeah,
tomorrow after 2.
sure.
All right.
All right. Just send us a text where exactly in the SVB you'll be at.
Yeah, it'll just be I'll send a text too, but it'll be on the 3rd floor, where
Yeah.
like all the grad students have our stuff.
Okay.
Okay.
Yeah.
Okay.
I think if you go to
Awesome.
reception and ask them to open up a study room, they'll open it for you because they've already done that for us.
Oh, they've done
And
it?
yeah,
Shit.
that's
Okay. Yeah.
for 205. That's what we did. We just ask. I mean, unless you get someone who's a jerk, but I think so far we've gotten a room.
Mhm. All right,
So,
Okay.
awesome. Yeah, that works out. That's good to know
all
for the
right,
future too.
All
all right.
right. See you.
All right, bye.
Anshu, thank you so much, brother.
Yeah,
Really
Yeah,
appreciate you, man.
no problem. Yeah.
really appreciate it. Thank you.
All right,
All right,
guys.
yeah. Bye.
Bye.